In this example, we're going to write the equation of a parabola that's already given to you as a graph. So if you notice, we have a parabola here with the x-intercepts -5 and 1, and then I gave you a third point, which happens to be the vertex for this one, -2, 5. And some other examples I've given you a point such as the y-intercept. But you could really look at any point that is on that parabola, and we like to choose points that land on the crosshatches really nicely because it makes it easier to solve. Well, the first thing we're going to do is identify our x-intercepts and write them as an equation x equals. So we have x equals -5 and we have x equals 1. The next thing you want to do is use your zero product property backwards to make these equations that are equal to 0. So I'm going to write x minus, not x minus 5, but when I set those equal to 0 and I go backwards on my zero product property, I'm actually, for x equals -5, to get it over to the left side, we have to add 5. So I have, as you see below, x plus 5 equals 0. For x equals 1, to get it over to the left with the x, you need to subtract 1. So I have x minus 1 equals 0. So we have two factors of our parabola written at the y equals 0. So we would know that those came from our solutions. Now we're going to set this equal to y, but we have a multiplier that we usually call a, and that's always in our quadratic equation, our general equation, y equals ax squared plus bx plus c. So that a is a multiplier, so we need to make sure that we find what that is, because not every equation is going to have 1 in front of your x squared as its coefficient. So we need to find out what that coefficient is going to be and how it affects the rest of the graph. So we're going to write this equation, y equals a times x plus 5 times x minus 1. We don't know what it is yet. But now, since we have a third point, we can take that point, -2, 5, and plug it in for x and y. And then we could solve for a from there. So let's go ahead and do that. The x is -2, so we're going to plug that in. And then the y is 5, so we're going to plug that in. Let's do it on the next screen. So 5 equals a times -2 plus 5 times 2 minus 1. And this is a really nice form because it's easy to do those simple calculations inside those parentheses. So you get 5 equals a times 3 times 1. So 5 equals a times 3. Divide both sides by 3. And you get 5/3 equals a. So this is a fraction or a mixed number. And that's what we want to put in front of our equation. Y equals 5/3 x plus 5 times x minus 1. This is one form of the equation. It's not normally the forms that we look at. So I'm going to go ahead and multiply through. But before I multiply the 5/3 through, I'm going to multiply the x plus 5 times x minus 1. It's just easier. You can use your FOIL method, or you can use our area model, our rectangle method here, and put everything in. So notice we have x plus 5 times x minus 1 gives us x squared, 5x, minus 1x, and minus 5. Combining those like terms will give us x squared plus 4x minus 5. And my last step is to multiply that 5/3 through. So I have 5/3 x squared plus 20/3 x minus 25/3. Just leave it like that. That's our equation of a parabola. That's all there is to it. Thanks for watching.